This question is another very simple and very interesting question in stereochemistry. A structure in a three-dimensional forms for a compound can be represented in various ways. As for example, a structure can be represented like this. This is known as a Newman projection. This is known as wedge projection. Wedge projection means there are three different types of lines are given here. One is a straight line, other is a thick line, the third one is a dotted line. A dotted line means it is behind the plane of the board or behind the plane of the paper. A ordinary line, a CBr, CC2H5, this line represents it is on the plane, whereas the thick line, the CH3 group, is in front of the plane. So, as far as this board is concerned, this hydrogen is behind the board, bromine and C2H5 are on the plane of the board, and CH3 is in front of the board. That is a three-dimensional, this is the convention used for representing a three-dimensional structure in this form. Now, two structures are given here. What is the relationship? As we have seen earlier in some of the questions, what is the relationship between the two? There is only one chiral center. If there is only one chiral center, there can only be two possibilities. There can be two different representations of the same compound, or they can be mirror images. But actually when it looks like, it does not seem to be mirror images there. Therefore, you find that when you look at this compound, now how will you arrive at it? From this wedge projection, since they are present in three different planes, now this has to be converted to a Newman projection. From the wedge projection, we may not be able to decide immediately whether the two are enantiomers or two representations of the same compound. Therefore, they are being converted to the Newman projection. How will you convert this wedge projection to a Newman projection? There is a very simple group. Two groups which are adjacent, as for example, two groups which are adjacent are being, as for example, these two groups which are adjacent are being pulled apart. So, they come to the front. As for example, this CH3 I am holding, assume I am here holding the CH3 and then H. I am trying to pull the two groups to the front. So, one group comes to my right, the other group comes to the left, they are horizontal groups, they are in front of the plane. Obviously, the other two groups, namely Br and C2H5, since we are not touching them, they go behind the plane. So, this is the equivalent Fischer projection for this wedge projection. Similarly, the equivalent Fischer projection for this, apply the same rule there, the two groups, the CH3 and C2H5, two adjacent groups, you try to pull them to the front, the two groups come. Groups which are horizontal, the convention is vertical groups are those are behind the plane. Horizontal groups in a Fischer projection are in front of the plane. So, CH3 and C2H5 are in front of the plane and Br and H are behind the plane. Similarly, in this case CH3 and H are in front of the plane and Br and C2H5 are behind the plane. Now, what is the relationship between the two? Apply the same rule. Keep one structure constant and try to make the second structure identical with the first structure. Now, Br matches exactly with Br, CH3 also matches exactly with the CH3, but when you bring the C2H5 here and H over here, that is by means of one interchange, it is the two compounds. As for example, all the things are same excepting that Br, CH3, now bring the H here and bring the C2H5 here. The two compounds are identical. This and this are identical. This structure has been converted to this by one exchange or one interchange. Therefore, the relationship between the two compounds are, the relationship actually is they are enantiomers. Even though they are present in the wedge projection, the relationship is 1 and 2 are related as enantiomers.